Hello, people. We're just going to wait a minute for others to show up. But if you want to go ahead and say hi in the chat, that would be awesome. Hi. Okay. So just to get people a couple of things, we're going to have more people waltzing in here, but these are the slides. You'll be able to follow along with me. And there's also the walkthrough code that we're going to be going over. So just want to give you access to that as well. Wait, that was just going to the panelists. Zoom has like the most obnoxious form of chat I've ever encountered, where you can't always tell who you're talking to on it because it just switches this little doohickey on you. All right, should be able to see those. So those are these slides. And I'll just pop them up on the screen real quick. So we got a pretty simple agenda today. Just going to spend the first 10 minutes waiting for people to arrive, and then kind of introduce ourselves and get ready to get set up. The most important thing to check out is this repo that I made, Hotel Node Basics. This has everything in it we're going to cover, so you can download this and use this as your own walkthrough code later. This is all the stuff we're going to be going over. The most important thing you need to do is you do need to have a place to send the data. Since this is a Lightstep workshop, we're using Lightstep. So I highly recommend getting one of these free accounts. You can sign up for this right now. If you just put your email and your name in, so you're not a robot, you'll get an account right now, and then you can use this. Walkthrough on your own while we're going over the slides. So recommend everyone just go ahead and start getting that set up. And I'm going to repost these links in a bit, just because, again, Zoom chat, kind of obnoxious. You can't see the prior chat history if you join late. So while we're waiting for people to do those things, go ahead and sign up. And if you could also just maybe post in the chat what brought you to this workshop. The way I like to run these is basically as a Q&A section. I'm going to be going over some basic overview and then reviewing the code, but I really like it to be interactive. So please ask questions. There's a Q&A tool you can use to ask questions, or you can just post them in the chat. If you can't see something or something's going wrong, let me know. And yeah, so to kick off introductions, my name is Ted Young. I work at Lightstep these days, but you'll probably recognize me more as one of the OpenTelemetry co-founders. So I ran the Open Tracing project for a long time, and then helped to merge it with the Open Census project to create OpenTelemetry, and been working on that for the past couple of years. And we're getting close to release candidate for tracing. So this is a good time to get involved both in the project and the community. One, to try it out, And two, because we're not quite in release candidate yet, this is a good opportunity to provide feedback. So if you do check this out, see some things ergonomically that you think could be better, or have any questions, you can hop into the community. We're pretty available, and I'll go over some of that stuff at the end where you can find us on the internet. But in the meantime, if people wouldn't mind just posting into the chat like what brought you here, what you're hoping to get out of it. Just a one-liner is fine. And when you do chat, make sure that 2 is set to panelists and attendees. I think it defaults to panelists, but then y'all can't see each other's chats. Cool. We got a quiet crowd this morning. The Python people were more active. Vishwash, nice to meet you. You're here from Boston, interested in learning OpenTelemetry or in general, distributed tracing in Node.js. You have come to the right workshop because that's exactly what we're going to cover. Just a general overview followed by just a walkthrough of how to actually use OpenTelemetry in code. Some Google search, I found this workshop. Glad you found it. Nice to meet you, Yuri. Oh, I should also mention there is, I have a Medium post on this as well. So let's give you guys this, add this. Great. Gorkum, nice to meet you as well. Glad you're here for the examples. And so we're coming up on 10 minutes. So just to repost this stuff so you all have access to it in case anyone showed up late. Here are the slides. David Chen, nice to meet you as well. You're using New Relic. Want to learn if OpenTelemetry is a good alternative. Interesting distinction I'll make here. OpenTelemetry is works with New Relic as well as Lightstep and a bunch of these different backends. And some New Relic people are actually working on OpenTelemetry with us. So it's not exactly a one versus the other, but we'll go into that distinction in a minute. Again, here are the slides, the walkthrough code, just to give people access to that. And then we really recommend getting a free account with us. These are free for life accounts. I push for us to make these specifically so that we can run these workshops and help people get started with OpenTelemetry. So all you have to do is just put in an email address, click you on a robot, and sign in, and you'll just have a free account right there. It has a data cap on it, but it's more than high enough to do local development and try out OpenTelemetry. So in my opinion, this is the easiest way to try OpenTelemetry right now versus having to like run a Docker container and do other stuff. Hi, Rob. Nice to meet you. Okay. So let's get into it. All right. So I'm not going to put my slides in full screen mode except for the, let me see, there's like a view here, there. This is as good as we're going to get. I just want to be able to have the Q&A open while I go through this. So again, feel free to ask questions as we go, and I'll stop and answer them as quick as I can. So first things first, if I haven't said it enough, please try to get an account, and if you like, follow along, or after we go through this in the workshop, maybe the best thing to do is then follow up right after this workshop running it yourself. So let's get started with an overview of what OpenTelemetry actually is. And the best way I think to start there is in the name itself. So what does telemetry mean? Because observability is a big space and it includes a bunch of different components that traditionally were all kind of glued together into a single system. And the main thing we're trying to do with OpenTelemetry is break that apart into sort of two major pieces. One is the telemetry system, which is the generation and transmission of data. And on the other end is the analysis of that data. And so OpenTelemetry is the generation and transmission portion of an observability system. And we're focused on that portion because we believe that portion is standardizable, because that portion is about describing what your system is doing. So at the heart of OpenTelemetry is sort of this standardization project around trying to come up with a sort of lingua franca for describing what distributed systems are doing. We don't currently have a common way of describing this across all programming languages and computer systems. So that's sort of like what started this project, was figuring out a way to make it so that any system could produce the same kind of data, and an analysis system could read that data and have some understanding of what it was without having to know much about the system that produced it. So how this works in practice, we'll just cover the basic architecture. So if you're running a process here, which is the green circle, the part that you install in your process is what's called the SDK. So the SDK is basically the OpenTelemetry client. These SDKs kind of work as a framework. So they have all the usual lifecycle hooks you would expect a framework to have. And they have plugins for exporting and for doing sampling techniques and different things like that. One notable thing is that you only access this SDK during setup and teardown. So the SDK is where you're configuring what you want to do with the data. But when it comes to actually generating the data within libraries or application code, you use this other layer called the API. So we actually have a strict separation between API and implementation. This is loose coupling, but it's especially important in a system like OpenTelemetry because it's a cross-cutting concern. All these packages out there on the internet are going to start relying on OpenTelemetry to generate data. And we want them to not bring in like a huge pile of dependencies when they do that. So, you know, if you have like your framework and your HTTP client and your SQL client and your application code, and they're all going to get instrumented with this API, that means they're going to be pulling in the API package. The API package itself doesn't really depend on a lot of other packages. So it's a very lightweight thing to pull into your system. And if you don't install an SDK, then the API is just a no-op. And one of the advantages here is it means that shared code like open source libraries and frameworks can add OpenTelemetry directly to them without worrying about hauling in a dependency chain that includes gRPC or something, or having dependency conflicts that result from that. It also allows you to swap out different implementations. People are like, why would I want a different implementation? One example is maybe an implementation written in C++. You could just swap out this whole JavaScript-based implementation and replace it with a C++ implementation, but not everyone would want a C++ implementation. Some people want a language native implementation. And so that's the other advantage, is this is swappable. The other major component in OpenTelemetry is what's called the collector. So this is where the data goes when it exits your system. Your system can export your data directly to a backend or analysis tool, But the advantage of running a collector, either in your local network or as a sidecar, is it's a place where you can do a lot of data processing. So we support a bunch of formats out of the box. OTLP is OpenTelemetry's native format. So that includes both tracing, metrics, eventually log data. So all that data kind of braided together in an efficient transport. But of course, there's a bunch of different backends out there already, and they use their own protocols. So the collector supports Zipkin, Jaeger, Prometheus out of the box. And of course, there's plugins for, X-Ray and Stackdriver and all that. All the different formats out there have exporter plugins. And you can run these exporters in the collector, but there are also language level exporters that you could install in the SDK. The other advantage the collector has is you can use that as a place to buffer your data, and you can also use it as a place to perform data processing. So adding data, changing data, ensuring, say, legacy attributes get updated to new attributes when you're changing things. And if you move all of that configuration and work out to the collector and just kind of leave your SDK running in default mode, pointed at a collector, that means if you're trying to adjust any of those features or anything about your observability data plane, you can do that by just redeploying the collectors. You don't have to redeploy or roll your services to make those changes. So that's another advantage for running a collector. But again, I want to stress you don't actually have to. OpenTelemetry tries to be sort of a la carte, so it is a complete telemetry system, but if you haul in one piece, it doesn't force you to haul in all of the other pieces. One thing that you won't find in OpenTelemetry, as I mentioned, is any kind of analysis system. So OpenTelemetry doesn't provide a backend. So if you use something like Jaeger or Zipkin or New Relic or Lightstep, you've got a backend where you're actually looking at this data and analyzing it in some way. And OpenTelemetry doesn't include that part because that part sort of is not standardizable. We don't want to pick a winner on that front. What we want to do is provide standardized data to encourage people to build more observability tools on top of it. So one thing I'm hoping to see with OpenTelemetry is that it makes it a lot easier for people to build interesting specialized analysis tools. Because in the past, if you wanted to build, say, a new analysis system, especially something for like distributed tracing, you would have to build all of this other stuff. And once you add in like all of the library plugins and everything else and getting it out there in all the different languages, it's just a huge pile of code. It's this gigantic pile of code that, in my opinion, dwarfs a lot of what you would end up having to write if you were just trying to do some analysis on top of that. So that's another advantage that I hope to see OpenTelemetry take on, is encouraging like a greater variety of analysis tools. And so for that reason, we don't provide our own analysis tool. We want you all to go build analysis tools or use stuff like Lightstep. The way we manage this giant pile of code is through what we call the OpenTelemetry specification. So the specification is a language neutral document. You can find it in the OpenTelemetry repo on the internet. And the way we work is we have an RFC process called OTEPs. So if people want to change how the specification works, they create an OTEP. We discuss it and review it there with maintainers of different languages to make sure this is something that's really going to work in a bunch of different languages and doesn't make too much assumptions about how languages work, whether it's a proper feature, prototype it and test it. And if we think it's good, then it gets added to the specification. And when the specification gets versioned, that then gets pushed out into all the different language special interest groups who then go implement that specification. And of course, as I mentioned before, the maintainers of these different groups participate in the specification process. So that's sort of how we keep things self-similar and on track among all the different language implementations. And that's how we do it in sort of a more big tent open source kind of way, as opposed to benevolent dictator or just a single company calling all the shots. We also have a governance committee and a technical committee The governance committee's elected position, I'm on that thing. And that's sort of the structure of OpenTelemetry. And you can actually find that if you go to GitHub, OpenTelemetry community. This repo will tell you everything you need to know about how the community works. It'll also point you to calendar. So this is where all of our meetings happen. We're a pretty meeting heavy group. We like to synchronize with each other a lot. You're all welcome to show up to these meetings. These are not expert only meetings. These are places you can come to ask questions, but this is where the real work is happening. You can also find us on Gitter for better or worse, mostly worse. We're hanging out on Gitter, and you can find the links to that stuff in here as well. So here's some Gitter. So we hang out in Gitter, and that's the other great place to come ask questions if you're looking to just chat with people. Okay, any questions at this point around this sort of basic overview of the project setup? We're going to get into distributed tracing and kind of what that is the next step. I really wish these webinars had the ability for people to just talk and interact. In future ones, we're going to try to see if we can get that set up, because like all this typing kind of slows everything down. But anyways, queue your questions up. I'm going to go on just so that we can keep on time. Great. So this next bit, I just want to go over distributed tracing and what are the core concepts behind that. This is like just the very basics, mental model that you kind of have to have in your head when you approach tracing, as opposed to just logging or metrics in the past. So just an example transaction. So this is the kind of thing that we want to measure and observe in OpenTelemetry, or distributed transactions. And so thinking of the world's most basic transaction, let's imagine that you have a client that's going to try to upload an image with a caption to a service, right? So let's say this is a mobile client, and you've taken a photo, you've got your caption, you want to upload it, so you're going to send it to your server. But of course, we know it's not this simple. Even the world's most basic setup for this, you would have not just one server, but something like a proxy that would then talk to an authentication server. Once you're authenticated, it will then upload the image to some temporary scratch disk, contact an application service, point it at the scratch disk, let that application service then upload that image and to some cloud storage, like let's say S3. Once it's uploaded the image to cloud storage and it knows where it is, it contacts the data service and stores the caption and the image URL there. And that data service is itself actually sitting in front of a SQL database and say like a Redis database for in-memory caching. So this is, to my mind, one of the world's most basic setups. I feel like I've been seeing setups like this for at least 20 years. Like this is a basic LAMP stack thing. And I just want to point out, even in the world's most basic system, you're not a monolith, right? You might think, oh, my app is a monolith, but even in this case, it's 1, 2, 3, 4, 5, 6, 7, 8 things involved that are connected to each other via a network. And when you're trying to debug what the system is doing, you want to be able to see this graph clearly. So this is sort of a service diagram view of the graph. So you can see all of the services that were involved, and that tells you some interesting data. But it doesn't tell you a lot of data about timing. Where did the time go? What thing was talking to what in what order? And so the way we tend to look at these call graphs of these transactions is a little bit differently. So we tend to make graphs that look kind of like this. So when you look at distributed tracing, you're going to see some displays that look like this. So to just explain what these are, each line represents an operation. These, in this case, they're color coded by, the service. So we've got green is the client, and then we've got our client here. The length of the line is how much time that client spent, that operation took. So you can see the client here took the most amount of time. The arrows here are where the network calls occurred. So you can see that this client then talked to the proxy, which then talked to the auth server, and then it had a local operation where it uploaded the image to scratch disk, then it talked to your app server talked to S3, and yada, yada, yada. So this kind of call graph is what we tend to use when we're eyeballing a trace and trying to get a sense about a couple of things. The first thing that you can figure out from looking at a graph like this is latency. You can figure out where all the time was spent. And it's not quite as simple as finding out which operation took the longest, because these operations are often waiting. So you could say, well, the client took the most amount of time, and that's true. But if you are trying to optimize this system, you want to figure out where that time actually went. And we call that the critical path. So in this case, you can see that the critical path was spent coming all the way down here, and the most amount of time was spent uploading to scratch disk and then uploading to S3. And then likewise, you can see potentially where the system was spent waiting for other services to do their job. And we've got a question. We are assuming all this is happening in a synchronous way, right? Well, it doesn't necessarily have to be synchronous. If you're thinking about how Node.js is asynchronous, you still have this idea of like an operation started, it was maybe doing some work, and then it was waiting for something before being awakened and continuing to do some work. So these moments where work isn't being done, that could be because the scheduler has gone off and done something else in the meantime. But these do add a synchronicity in that respect. In terms of the respect of like, I do a transaction and then that transaction kicks off a background job later, or I put something on a message queue and then something pulls it off the message queue later. That can also be modeled with distributed tracing. And the way we tend to think about those is a graph of transactions or traces that are linked together. So this is one trace. And if you were to have this then kick off a background job later, then that background job would be another trace that was then linked to this trace. So hopefully that makes sense. If you're coming from the open tracing side of the fence, by the way, we used to model that as one giant trace, and the span relationships here, we call an operation a span, by the way. These span relationships were either marked as synchronous or asynchronous relationships. So you either said the span was a child of, or the span followed from. But in OpenTelemetry, we say everything is just a parent-child relationship. And then we have another thing called links that allow you to link traces together. So that's how that works. That's a good question. Okay, so the other thing we want to look at here is we want to look at errors, right? When you're root causing something, you want to know about errors. You want to be monitoring for errors. And in distributed tracing, errors are considered to be an operation level event. So this is slightly different from an exception, right? Exceptions can happen, and an exception might lead to an error, or it might be handled and be fine. But an error means that an operation has failed, right? This is not what it meant to do. And what an operation failing means can be kind of subjective. OpenTelemetry does come out of the box with some opinions, 500s are a failure, things like that. But the first thing you want to know is where in this system, which operation was failing. So you might be getting a 500 or an error back here on your client, but where did that originate? And so you want to be able to find where in your system very quickly, which operations did that. And we're talking about this just in terms of a single graph right now, but of course, you're also aggregating these data. So you want to know like what percentage of errors over time did a certain operation have. And this is mostly where you're setting up your alerting, is kind of at this operational or span level. And you might be setting up alerting around errors and failures, or you might be setting up alerting around latency issues, because those are also pernicious. It's almost easier to debug an error than it is to debug the question, why is it slow? When someone's like, this is too slow, we're losing money because it's too slow, or our users are frustrated because it's too slow. Figuring out where that latency is, that is tricky. And that is one of the things that distributed tracing makes a lot easier to do, because you've already gathered all the information you need in order to do that analysis automatically, rather than having to set up a bunch of stuff by hand to figure it out on an ad hoc basis. Last but not least, operation level information is great, but it's not enough. You, of course, want to have fine-grained information. These are called logs. Traditionally, in OpenTelemetry, we call these events, just to differentiate between traditional logging. And OpenTelemetry will be adding some log facilities in the future so that we can integrate with existing logging tools. And so for that reason, we call these trace events, but they're logs. They're just logs. It's just really good structured logging. And what makes these really good structured logging is all the correlations that you get out of this. In traditional tools, if you wanted to be able to like correlate your events and search for them, you would have to, one, have structured data, ideally, or you're in parser hell. And two, you're going to want to have each one of those logs be indexed with a bunch of key value pairs, so that if you're putting it into a database, you can search for them later. OpenTelemetry makes this a lot easier because you're putting all of those key value, you can put those key value pairs on the events. This is structured logging, but you can also put them on at the span level. So you say, for this operation, these are all the things that were relevant to this operation. And all of those events are automatically indexed according to those operational level attributes. And then likewise, you have these really great attributes, which is tell me all of the events that occurred in this span. So there's an identifier associated with just this span, a unique identifier. And likewise, you're going to want to say, show me all the events that occurred in this trace. And to do that, you have a transactional identifier, which is called a trace ID. And for me, this is huge. This was my biggest pain point with logging in the past, is you have all of these logs, right? And as your system scales up, you end up with more and more logs. And if you're trying to find the logs that are associated with a particular transaction, the bigger your system gets, the smaller the percentage of logs are relevant to that transaction, the fewer servers interacted with that transaction, and finding just those logs that were involved in that transaction becomes more and more annoying. You end up gluing together a bunch of request IDs, and it's sort of like this hunt you have to play where you find one log, and then from that you can search for some other ones, and then some other ones, and then maybe you find some extra ones by accident. You want to lose those. I did not realize how much time I was spent grepping around in my logs and dealing with them, even with like a logging indexing service of some kind, until I switched over to tracing and realized you just kind of get a lot of the searches you were trying to do out of the box. Okay, so I'm going to stop here and answer some questions. If you have different runtimes, JVM, how does it work? Single trace or multiple trace? So it would be a single trace. So in this example here, assume each one of these systems is written in a different language. They are all participating in the same trace because all of these languages have an API that is designed against the same spec, and they all produce the same data. The next question is the difference between a trace and a span. That's another really great question. So the difference is a span represents a single operation, and a trace represents all of the operations within that transaction. So that's the difference. It's you could think of the trace as the graph, and the spans are the nodes in the graph. Okay, gonna move a little quick because we're a little bit behind time, though I'm happy going over time, though I know other people may have places they gotta go. So there's one big concept that I want to get in people's heads around how distributed tracing works. How is it that you can get these nice transactional IDs like a trace ID or these operational IDs like a span ID? In order to do that, you have to have some kind of context that gets propagated. Like if I create a trace ID at the beginning, that trace ID is going to have to get handed around. Otherwise, like, how is this service down here going to know that it's part of the same trace that this service is up here? So that is the core of what distributed tracing is, and we call that context propagation. So if you understand context propagation, then you understand the model of distributed tracing, and everything else falls into place. So just to quickly review that, imagine you've got a client and a server. You've got some operations happening in the client, and then a network call to the server and some operations happening there. The way this works in OpenTelemetry is we have something called a context object, which follows the operation. So it follows the course of execution in your code. So in some languages, if you're coming from, say, Java or Python, you might have encountered like MDS or Python context, and OpenTelemetry context is very similar, and we actually leverage existing context objects if they exist. So in Go, for example, there's an existing context object, and in JavaScript, there's like a couple. So you can't depend on one particular one being there. So in JavaScript, there's an OpenTelemetry context that will map onto whatever available context propagation mechanism is under the hood. That's some details. All you need to know is that there's a context that's always following the flow of execution. And when that context wants to go from one service to the next, we call that propagation. And so what that means is you're going to take the contents of that context and you're going to serialize them and add them as metadata onto your request. So if it's an HTTP request, you're going to add this context information as HTTP headers. So serializing a context and adding it to a request is called inject, and then deserializing it and pulling it off of a request on the other end is called extract. And once a context is extracted, it can then be turned into an in-memory context and continue following the flow of execution. And so this is really what distributed tracing means. It means having this facility already built for you so that this context is automatically flowing through your system. And once you have this context flowing, then it's very easy to like put something into that context, like a trace ID, and then have it flow all the way through your system so that you can then pull it off of, your context way down here in another system. One thing I should note is when you're propagating this context, obviously the client and the server has to agree on what kind of data it's serializing and where it's putting that data. So they have to agree on what kind of HTTP headers they're using. In the past, this was annoying because there's no standard. So another thing we've been working on is getting these tracing headers added to HTTP. So we've been working within the W3C to add a set of tracing headers. Just briefly, the official header is coming. One group is called trace context. So that'll include two headers, trace parent and trace state. Trace parent includes the trace ID, which is that transactional ID I was talking about, and the span ID, which is the ID of the parent operation that was sending you the trace. And then there's some internal details around trace state, a sampling flag. You don't really have to worry about that stuff. Just know that these are the new standardized headers coming in the future. They're available now, but existing systems might be using older headers like B3 from Zipkin, for example. There's another set of headers in the works called baggage. These baggage headers are basically just arbitrary key value pairs. So trace parent is all the tracing specific stuff you need to get the trace going. And baggage is just any additional information you want to add there that's just along for the ride. We won't cover baggage in this workshop, but that's a really basic facility in OpenTelemetry that you can use to say, If you have a project ID available in one place, but it's like really expensive to grab that, you'd have to make an extra database call down the line to get that project ID. Rather than doing that, you could flow that project ID using baggage and then have access to it in both places. So that's distributed tracing, that's context propagation. So now we're going to switch to looking at some actual code. So to do this, all of this code here is in this repo, Hotel Node Basics. So you can take this with you and look at it yourself. All you have to do when you open it up, the only thing you need to set up to actually make it work is you need to add an access token here to talk to Lightstep. And you can find that if you're logged into Lightstep, you go here to your settings page, you scroll down, there'll be an access token. So you just take that thing and you just copy paste it into here. So the way you get started with this is what's called an OpenTelemetry distro. You can use OpenTelemetry out of the box, but it's easier to have OpenTelemetry pre-configured to talk to whatever backend you're talking to, since most of the configuration is about, am I talking to Lightstep? Am I talking to Jaeger? Am I talking to X-Ray or something like that? So to help with that, we've come up with a concept of OpenTelemetry distros, which is just like a little configuration layer that's prepackaged for you. So in this case, the Lightstep distro is called the OpenTelemetry launchers. So if you just install the OpenTelemetry launcher, latest version is 12, this will pull in all of the correct OpenTelemetry dependencies that match this version of the launcher. So this is the easy way to install OpenTelemetry. If you're using Lightstep, if you're using Jaeger or another system, you can look up the installation instructions in the core documentation. But when you go to configure it, all you need to put in is your access token. The service name represents what service you're talking to, and then a couple optional parameters. The version, this is a useful resource to put in so that you can look for regressions across deployments and things like that. And then last but not least, what propagators are you using? So I mentioned there's the trace context propagator. That's the new one coming in the future. B3 is an existing one, and you can actually use both at the same time if you like, if you're trying to transition from one to the other. So that's just real quick. So the actual server here, this is just like the world's silliest thing. Someone asked, can you set this data as environment variables? Yes, you can. So if you go look at our launcher here, we list everything that you can set, and you can set all of this stuff as environment variables. So yeah, that's actually, I would recommend that. I wasn't doing it in this this walkthrough, but that lets you control this stuff as an operator. And yeah, it also means it's easy to, if you're doing all this through environment variables, then this initialization script here becomes very reusable. So the way OpenTelemetry works is we have plugins for each piece of hopefully everything you're using. So this is getting back to this thing here. In order for context propagation to work, you need to have at least your web service or framework instrumented, and then any clients, like outbound clients, need to be instrumented as well. So OpenTelemetry comes with a bunch of instrumentation by default, but make sure that the stuff you're using is currently supported because it is a new project. We haven't gotten around to instrumenting every framework yet. There's actually a great way to get involved or kind of learn OpenTelemetry is pick a framework or pick a library and look at how existing things have been instrumented and see if you can instrument that library and add it in. But going back to the code, all this server is this is just a hello world server written in Express. So you just start up Express, and then down at the bottom, we're just sending hello world. And all of our client is is just a basic HTTP request. And then we're just going in a loop and making 5 requests. So that's all we're doing here. And you'll notice that there's no instrumentation here. We're not pulling in OpenTelemetry or anything like that in this client. In the server here, we're doing some stuff to show off the API, but I want to stress that out of the box, you don't actually have to add any code if the libraries you're using are already instrumented. And that instrumentation will get installed during the bootstrap process if it's available. So the main thing that you have to remember when you're setting this up for Node is you need to load OpenTelemetry before you load your application or any of your dependencies. So anything that you require before OpenTelemetry is loaded won't get monkey patched with instrumentation. So the important way to do this is just ensure that OpenTelemetry is loaded first. Right now, loading is asynchronous. We want to move to a synchronous model because this is a little annoying, but just the reason it's asynchronous is to give an opportunity to automatically detect resources for you. So things like what Kubernetes pod am I in, what's my host ID, et cetera. And to detect some of those resources, you might need to make like an HTTP request or do some asynchronous operation. So because something like that might occur, we currently load asynchronously. And to go over how loading works, our launcher just pre-configures the OpenTelemetry SDK. So all this does is lets you have a couple of variables here. We set up the rest and you get back the OpenTelemetry SDK. The way the SDK works is it's just a promise. You start it, and once it's loaded, then require your application. So I think this is like a really good copy-paste pattern to learn, which is all you're doing is changing your entry point. So if you used to start your server by saying node server.js, all you're doing now is adding server init, requiring your original entry point, and then saying node server init instead of node server. And so this is an easy way to add OpenTelemetry to all of your services without having to get in and muck with any application code. So I recommend getting started with OpenTelemetry, sort of like what we're doing in this client example, which is just making this init file and letting it auto-instrument your service and checking that that works. Important thing you have to do in Node, you don't have to do this in every language, but in Node, you do also have to manage shutdown. Otherwise, you might lose some data if your system stops without OpenTelemetry being notified. And the way that works is the SDK has a shutdown promise, and you can just attach that to all of your different shutdown signals, or if you have a shutdown code already going in your application, then that's where you want to put shutdown. So that's it for the SDK. There's just SDK start and SDK shutdown, and that will get you instrumentation out of the box. I'm going to go over, actually, first, let me just show you this in the works. So if I just run my server here, you can see that it's loading HTTP instrumentation and it's loading Express. And then here, I'm just going to run my client real quick. So it loads HTTP. It says hello world 5 times. I'm going to close my server so that it shuts down and flushes everything. Otherwise, it'll flush on a timer or when its buffer gets full. And then if I go here into my backend, I can see that data is coming in. And if I look at this trace, I can see the trace. So in this case, I've got a client and a server. The automatic instrumentation has been created for the client request out of HTTP. And on the server side, we've got these spans created by Express. And just to go over the data that you're getting out of this. If I can move this Zoom Chrome out of my way. So on the client, we didn't actually add any instrumentation code, but you can see that there is a span representing the request, and it's already loaded up quite a bit of information. And all of this information is standardizing. So host, method, status code. We've standardized this. We call these semantic conventions. So regardless of what language or library is emitting an HTTP request, we want that to be recorded the same way. And you can also see here where it says instrumentation name, this is letting you know what instrumentation was actually managing this span. So you can here say it's the OpenTelemetry plugin that was managing it. And then here on the server side, we can see that it was actually, even though this is Express, it was HTTP under the hood, because that's what's actually doing the network call, network handling in Express. And here you have the server side HTTP information. And then you'll notice we have an error going on down here. So we have this internal span that's been marked as an error. And you can see it's got some information, some events put on it as well. So we have a start event, a timeout event that we've added. And here you can see an exception that's been recorded. So in the remainder of this time, I'm going to just go over the API calls that let you add data to these spans and manage these spans. But again, I want to stress, when you're starting this from scratch and you're trying to get your system instrumented, you should try, before going in and adding a bunch of API calls by hand, to get context propagation flowing just with library instrumentation. Because you want to have an end-to-end trace that's complete with this high-level information before going in and digging in and adding more details in various spots, because having a broken trace isn't very interesting. So even though the API is very important to learn how to do, it's also useful to just get the trace out the door. And yes, this session is being recorded. This was just asked, so you'll get a link to this session after the fact. And also this blog post that I wrote here covers all of this same information. So this will walk you through actually setting up the code in detail. I don't want to make you guys wait while I type all this in. Great. Yeah, and apologies if people have to go early. It looks like we're going to run over time a little bit. But yeah, you'll get the recording afterwards. Okay, so let's actually check out what it means to write instrumentation in OpenTelemetry. The most important thing you're going to want to do as an application developer is, in your application code, you're going to want to add application level attributes and events. So knowing HTTP and network information is great, but you're also going to have application level information that would be really useful. So for example, if you have a concept of an account ID or a project ID, that might be a useful attribute to add in your controller. For example, if you're starting to see errors, like I'm getting 500s, and it's one thing to notice that you're getting 500s from an endpoint across the board versus you're getting 500s, but they're localized to a specific set of projects. That would tell you a lot about where you should start looking or what the problem might actually be. So any kind of attributes that will allow you to segment your data when you're trying to investigate it later are important to add. And you don't have to create your own spans. I think when I see other examples of how to use OpenTelemetry, they all kind of focus on how spans work and like, here's how you make spans. And yes, it's true, you do need to make spans to make OpenTelemetry work. But it's much better, in my opinion, to just be adding all of this data to the existing span that was already covering what your handler was doing, rather than creating lots and lots of tiny spans and having all of these attributes and events smeared out across a lot of spans. And the reason for that is, one, overhead. Spans are more heavyweight than events and attributes. And the other is indexing. You're going to get better indexing if all of your spans, if you have fewer spans with more attributes on them, will give you better instrumenting than lots of little spans with very few attributes on each span. And the reason for that is, like most systems these days, they tend to allow you to do the querying you're looking for kind of on the span level. It's harder to say, like, find traces where some span has project ID on it and some other span has like some other ID. So fewer spans. Also, managing spans, you'll see here, is a little bit of boilerplate. And so when you do manage your spans, really you should be trying to put that into your framework or a wrapper function or anywhere but in your application code. You don't really want to litter your application code with a bunch of spammy boilerplate. But we're going to do that here just to show you how that works. So really all you're ever doing in OpenTelemetry in general is grabbing the current span, adding some attributes to it, and adding some events to it. So attributes are setting the indexes that you want to search for later, and the events, that's just the logging that you want to do. And you could even look at taking your existing logging solution and making a little shim for it. So rather than logging to just your old logger, it can also say for every log, it just grabs the current span. And if there is one, it adds that log as an event. So that's an easy way to funnel your existing logs into your tracing system. And so for the most part, that's all you should be doing in your application code. However, there are a couple extra things that are good to know about. One is, how do you manage a span? You're going to have, at some point, you're going to have operations that you want to carve out where you want to know, like, the error rates specific to this operation, the latency specific to this operation. And to do that, you create a span that wraps that operation in a context. And that's a two-part procedure. The first part is just starting the span. So when you start a span, you need a handle to a tracer. Actually, in Node.js, you need a tracer in general. And the way you get a tracer is at the package level. You just grab the OpenTelemetry API, grab the trace package out of that, and say get tracer. And then you want to name that tracer after the package that you're in. So basically, there should be a one-to-one relationship between a package and a tracer. And this information here, when you name a tracer, that's this information showing up here. Oh, so much Zoom Chrome. So this right here, instrumentation name. So you can see the child span we created here is coming from our OTel Node Basics server, because that's what we've named this here. So that's like the basic pattern you want to follow, is just in every package where you're going to use the API, create a tracer, name it after your package, and then you can use that tracer to just grab the current span. So this is the span that was created by the Express instrumentation that's already available, and that's why you don't have to create your own. But if you want to create your own and then set it up so that get current span returns it, you first say start span, name the span after the operation. You want to give it a unique, distinct name. And you want this to be a name that represents a class of operations, not just operation 1, 2, 3. It should just be operation. And that will give you a new span. However, get current span won't return this new span. Get current span will still continue to return the old span, even though this new span will automatically be added to the trace as a child of a current span if it's there. So if you want your child span to be set up as the current span, you call with span and create a closure. So the basic set of events here is you have a current span. You want to create a child span. So you say start span, you now have a child, and then you want to set that up as the current span by saying with span. And then within this closure, get current span will now return the child span. And that's it. That's tracing. One final bit I should mention is exceptions. Actually, I forgot to cover this. when you want to record an exception, that's two pieces. One, exceptions are recorded as events, but we want them to be properly formatted. So we just have a piece of sugar called record exception. And if you pass that an exception, that's just ensuring that, you know, when it shows up in your backend, it's formatted properly. So rather than just saying add event, you want to say record exception to add an exception. But adding an exception won't on its own cause the span to become an error. And in order to do that, you also have to set the status of a span as an error. Now, obviously, you could wrap these two things up in a helper function that does both for you. But we leave them distinct because, you know, if you've caught an exception, you have handled it and the operation is going to continue fine, but you still want to record it. And in theory, you could have an operation fail, but not have an exception that was associated with that failure. So that's why recording exceptions and setting the status on a span are two separate operations. And we used to have a fancy system of errors that came out of Google and gRPC. This was too annoying. So just so you know, in the next version of OpenTelemetry, this is just going to be called status code, and it's just going to have, you know, two versions, error and okay, and then it will be unset by default. So all you will have to do there is set it to error. But the current version, it's this like slightly longer thing. So just let you know the next version, that's going to get a little simpler. And that is it. And we're right at 10. Look at that. Okie dokie. Oh my God, I forgot about span end. Oh God, this is actually important. So when you start a span, way up here, so I started my span, in order to measure the duration of the span and send it to be exported, you have to end the span. So once the operation is complete, you have to call span end. You can, of course, just grab the current span and call it that way, but you have to do this. If you fail to end a span, then you'll end up with a leak because the span will just be open in the background and it won't get garbage collected. So forgot that earlier. Hopefully you're still watching. So end span is kind of the twin of start span. And you can see with this boilerplate why you would want to not be doing this stuff in your application code. You want to move it out into like a wrapper helper function so it can work more like we're doing here with Express, where we can just install it automatically and then just be accessing the current span like this. This is way cleaner than gumming up your application code with all this with span nonsense. Okay, so truly done. We got some questions. And please add more questions at this time. I'm happy to stick around and answer some. Hopefully, I think Swaran's probably left, but I will answer his question so you can hear it in the recording. Wouldn't APM tools highlight about 500? Should I need to write traces spans? It's true. You currently can get, you know, warnings about 500 errors in logs and existing monitoring tools. It's not like that's a new thing that you get out of distributed tracing, knowing that 500's occurred. What you get is knowing that if there's an error, so if I'm here and I get alerted about there being an error, so let me send some more data. So just sending more data to the system. You're like, oh, look, an error. Or let's say I have error alerts popping up because I've set up some alerting. And then you're like, what the hey happened with this error? You can just look at it and bam, you not just have this error, you have every single thing that happened in that transaction that led up to that error or was associated with it. And that's really valuable. And then you can go from like looking at this error and being like, okay, I see I've got an error here. And that error happened on this hello handler. So what are other things that were going on with this hello route? And then you can look here and find all of the hello server spans that were occurring. And be able to kind of do queries on that and be like, well, what's happening on this one? Like, oh, okay, this one also has an error. And you can kind of go back and forth between looking at statistical data and then getting exemplars of that statistical data. So if it's saying like, hey, a certain percentage of your transactions are really slow, you might want to say, well, what actually happened in those transactions? And it's easy to get example traces that will then give you a sense of the actual operations. And so I think sort of like if you ever have gone from like manual code formatting and then you went to a tool that started to automatically format your code, and then you go back to manual formatting, you're like, oh my God, this is so annoying. I'm spending so much time and energy just formatting my code. I can't live without this automated formatting. Tracing to me feels kind of like that. Are you able to do things you just couldn't do in the past? No, we've been monitoring applications for decades, but it makes it a lot easier and it makes you a lot faster. So root causing systems becomes a much more agile process. And the kind of automated instrumentation and automated analysis you can start to build on top of these things becomes a lot richer because the data is much, much more structured, right? You might have all these data in logs, but that log data isn't connected up in a graph properly. So what tracing is giving you is taking all of that existing data that you had and putting into a graph so that you can actually, use your database tools to go look at it properly. So that's the real critical key about what distributed tracing gives you. And I really would recommend people give this stuff a try. I found it for big systems to be like life-changing once you get used to using these workflows. And I would not want to go back to logs. That is my take. Of course, I'm a mouth-frothing convert to this stuff, but I would encourage you to give it a shot and see if you're in the same boat. Cool. So the key is very structured representation of, yes, exactly. It's a forest. It's always a forest, but if you see one tree, you want to know like, well, what are all the other trees related to that tree? And that if you are using logging today, just look with your existing tools and notice how much time you're spending like gathering and piecing data together versus just analyzing that data. And once you'll notice that if it takes no time at all to gather that data, you can just look around, you're going to be encouraged to like look around a lot more. It becomes, since it's so easy to investigate your system, you're going to do more investigation. Not to mention, having a bunch of statistical tools. So this isn't going to work very well because we're just sending in a tiny amount of data, so there's no real statistics going on. But you can see here, right, that there's a latency histogram. So we've got some requests out here that were way slower than these requests, right? And so I might be like, well, what are these things? And here we go. Here's the things that were all over here. And weirdly, there's a couple hello client spans that were like extra slow. Like, what's going on with that? Stuff like that. So that's kind of how you use it. Some other questions. I will be having a large number of methods in my application code, and do I need to start a span for each method? Yes. Not every method. I want to make it clear. It's not like there's a one-to-one relationship between a span and a function. It can kind of look like that because it's a closure, but that you really don't need that many. Like if you look here, like one span representing your handler is really enough. We've got a little bit of extra junk coming in from Express, but these are just pieces of middleware that are happening very short, but it's just a single operation is really good enough. And then if you had sub operations, they might be for things like if you then make an HTTP request or a database request. So it's just the large scale operations that you want to wrap up in a span, not every individual function. So Eswaran says, we're using Datadog. They've got some inbuilt tracers. Don't know how effective they are. No comment. Can't comment on that one. Sorry. I will say though, just to be nice, Datadog is also getting involved in the OpenTelemetry stuff. So they'll be accepting OpenTelemetry data at some point if they aren't already. Cool. So we're over time. Thank you everyone who stuck around. More questions, great. Is there a centralized approach for maintaining the spans? What do you mean by maintaining? This is where I wish we had voice. Adding spans for every handler. Yes, yes. You want to centralize this stuff. So in this case, we're not generating this span. All of these spans, both here and here, are coming out of automatic instrumentation. So you notice here, like I didn't wrap this handler myself. There's a piece of express middleware that's doing that for me. And OpenTelemetry, if you've installed the instrumentation packages for the libraries that you're using, OpenTelemetry will auto-load them for you. So I'm not getting into the deets around that. That's like some under the hood stuff that you can learn just by looking at an existing piece of instrumentation. But yes, it's much better to just have this stuff centralized. So for example, in this client, we're not even pulling in the OpenTelemetry API, right? It's just HTTP GET is now auto-instrumented. So anywhere in your code where you're making a request now, you're going to see a span for it, and it'll participate in the trace if one exists. And that's really the way you want to set it up. Like, I don't think you want to be going and making spans everywhere. You want to find a way to just wrap up your application code so that it's getting handled in a centralized spot. So stuff like middleware in your web framework is a good place to put it. Cool beans. So I think I do have to go at this point. I hope that was helpful. You can follow up, by the way, if you have future questions, you can follow up in our Discord server. Let me give you the link to that. Boop, boop, down here at the end. Yeah. So me and Austin tend to hang out in Discord. So this is the Lightstep Discord. So if you want to continue the conversation, just pop over there and we can keep talking. Hope this was helpful. Appreciate you all from coming. You can also find me on Twitter. I'm Ted Suo on Twitter if you use the tweets. So just to give you that stuff. So I answer my DMs there if you have DMs, and you can follow my account there. And I'm writing a lot of these tutorials and workshops and things right now. So it's a pretty low volume account except for postings around OpenTelemetry. So if that's what you're looking for on Twitter, you can get it there. Cool. All right, you all. This was lots of fun. See you around on the internet, hopefully.